Hi, good day. How are you? Today I'm gonna do another video on the refrigeration and HVAC mechanic red seal license exam reviewer. And the topic for today is regarding the calculation of water temperature entering the chiller and also the rise in temperature. So here is our problem. A 60-ton chiller circulates 160 US gallons of water. What is the temperature rise? If the water supply temperature is 45 Fahrenheit, determine the temperature of the water entering the chiller. So first, we need to determine our given information. So we've got the cooling capacity of the chiller is 60 tons and the water flow rate or GPM of 160 US gallons per minute. Also, we have the supply temperature equal to 45 Fahrenheit. So here we've got two unknowns: the temperature rise or the change in temperature, the delta T, and the temperature temperature of water entering the chiller. It's also called the return temperature. So solution. So we solve first for the temperature rise or the delta T. First task is to convert the tons that we are given, tons of capacity, into BTU per hour. So 60 tons, we multiply the conversion factor of 12,000 BTU per hour per ton, and so we get 720,000 BTU per hour capacity. And we need to rearrange the main equation of cooling capacity. Q equals 500 times GPM times delta T in order to come up with the delta T being Q divided by quantity 500 times GPM. So now that we have rearranged the formula, we can substitute the capacity that we calculated earlier, 720,000 BTU per hour, divided by 500 being a constant, and the 160 gallons per minute. And then we will get an answer of 9 Fahrenheit delta T or temperature rise. So that's the answer for the first part of the question. And the second part is we are told to calculate the return temperature. So the return temperature is equal to delta T plus the supply temperature. And so we get the return temperature of delta T that we calculated equal to 9, and the supply temperature which was given being 45 degrees Fahrenheit. So we just add the two together, 9 plus 45, and we get return temperature of 54 Fahrenheit. That's the answer to the second question. If you have comments, please let me know in the comments section below. And that's it for this video, and I'll see you again on the next video. Cheers, take care.